Okay, hello everyone, and thank you for logging in today. My name is Michael Downey, and I'd like to welcome you to today's webinar on the AWRI's Ferment Simulator tool. I'd also like to welcome today's presenter, Tadro Abbott, a project engineer with the AWRI. In today's presentation, Tadro will disclose details around the remodeling of this free tool, notably a transformation from a spreadsheet to a web-based application. But before I hand over to Tadro to tell us more about these changes, a couple of quick notes on what to expect for those that are new to AWRI webinars. The format for today's webinar is a PowerPoint style presentation followed by a Q&A. We do encourage attendees to get involved and interact. So to ask a question, please type into the questions pane of your control panel in the bottom right corner of your screen. For those with access to a microphone or anyone that's dialed in on a phone, there's also the option of speaking with Tadro directly by clicking the raise hand button. This is located in the top left section of your control panel. Questions will be answered at the end of the session, but please feel free to send through your questions at any stage. Okay, I'm now going to hand over to Tadro to get us started.
Cool, thanks Michael. Hi everyone. My name is Tadro and I'm a project engineer with the AWRI's Commercial Services. I've been looking at the redevelopment of the Ferment Simulator for the last couple of years. So a quick acknowledgement before we kick off. Most of the algorithms used within the simulator were developed by Dr. Richard Mulak, so thanks go to him for that work, and that work was originally done with funding from Wine Australia. So his original models were housed in an Excel spreadsheet kind of tool that was available for free on our website, which you may or may not have had any experience with. It was really clever in what it was trying to achieve, but was a bit of a clunky interface and I guess a steep learning curve for a lot of people. But it was a good first implementation, had some cool dashboards that gave an overview of your tank farm and how all your fermenters were looking, graphed everything in quite a lot of detail. So basically what we've done is worked with a web developer to redesign the interface to make something a lot more intuitive and easy to learn. We've got new powerful dashboards, added some new functionality to the models, and the whole thing is now hosted in the cloud so that you can access the data wherever you are with an internet connection. So I'll talk a bit more about the algorithms and predicting problematic ferments because that's what the simulator kind of centers around, but it's not all that it's about. And so if you're not really interested in the prediction but still want a free cloud-based ferment tracking tool, then it's probably still worth having a look at. So the simulator is based on an engineering model. Most process industries of any kind of scale employ some kind of process modeling and system control. The models give feedback on the status of the process, forecast or control heating and cooling, and identify or even respond to issues as they arise. Many people, including myself, can be quite skeptical about ferment modeling, and I was when I first started looking at it, because ferments are just such complex things, and there are many reasons why you might get a stuck ferment determined by many important parameters that most of us don't even measure. So, only some people are measuring YAN in the winery. If you're propagating, you might measure yeast viability, but you're almost certainly not measuring vitality, oxygen, thiamine, and other complex nutrients. So, how can you expect to model a ferment if you're not taking these things into account? Well, we aren't really trying to build a model of a ferment from first principles like that. So we know the general shape that a ferment curve takes and the equations that describe it. So it's more a case of fitting that general shape to the behavior that we observe in the ferment, irrespective of the actual causes of that behavior that we observe. So to give you an example, I've got some ferment data here just plotted to a single simple logistic equation. So the actual curves in the ferment simulator are a lot more complex than this, but this will give you a basic idea. We've got a bunch of model parameters on the right there, and these basically describe the shape of the curve. So as we change these parameters, the curve starts to change shape. So we guess different values for the important parameters for the curve until that curve matches the measurements that you've taken. So when the curve matches the data, then we know we have the right parameters, and once we have the right parameters, we've got an equation that describes what this specific ferment is doing, and we can use that to project out and predict what it's going to do in the future. So we don't actually care why it's doing what it's doing. As long as we can match the curve, we can predict what it might do in the future. So these are the main equations that the model's built on. You don't need to understand them, but there are a bunch of parameters in this model. So some we calculate from the information that you give. Some are fixed for wine fermentation, and others, these red ones, so KS, and these other ones that sit behind these main equations, we basically guess until we match the measurements that you've taken from the tank. So you might say, you know, most of my ferment curves aren't smooth though, so they're not going to fit a nice function. And you're right, there are a heap of different things that we do in the winery that can put a kink in the ferment curve. Things like changing temperature, adding nutrients, but as long as we tell the simulator that we're doing them, it can compensate and move with it. So this first graph, the green line here is the simulation, is showing how it moves with changes in temperature. So we're initially starting at about 20 and then dropping down to 14, and then on day 12 raising back up to 20 again, and you can see how the curve kind of bends with those temperature changes. If we do something more drastic like add juice, we get a much greater kink in the curve, but the model still takes this in stride and recorrects itself. So there are a number of different events that the simulator is modeling, including, you know, temperature changes, pump overs and other mixing, nutrient additions, juice additions, dilution that might occur with other adds, and yeast additions from overseeding. And as long as we tell the model to expect these, it can adapt with it. So particle swarm optimization is something that we use to basically help us to target our guesses. So without this, we would just be guessing randomly and hoping that we happened upon the right answer for the model parameters. It might be quick or it might take forever. So with PSO, we basically make a bunch or a swarm of guesses at once, and then we stop and calculate which guess was the closest, and then redirect all other guesses towards that best guess. And then we recalculate which one's the best again, and keep doing that until all of the guesses basically converge on the right answer. So this example on the screen is in 2 dimensions. Inside the simulator, we're doing it in 6. So once the simulator has made its prediction, what does it do? So these are the new dashboard widgets that we've designed that give you a quick overview of all the ferments that you've got going in the winery, and a quick overview of which ones may be struggling. So the gauges are all centered around the desired duration, which is something that you define when you set up the ferment, and is basically how long you expect or want it to take. The gauge dial shows the predicted duration from the simulation, and the simulator makes no judgment on its own about what a slow or a fast ferment is. It's simply comparing what it's predicting with what you said you wanted to happen. So we've also got progress bars of how far through the BOME the ferment's gone, and current status from the last measurement. And for any ferments that are struggling, we've got these warnings that pop up at the bottom of the module. So if you do have a ferment that's struggling, we've got 2 different modes for using the models to investigate different interventions that you might do before, you know, actually going out to the tank. You could also use these modes, you know, retroactively to kind of go back and say, well, how could I have managed this ferment better? So I'll start to give you some demos now. The site's currently in kind of a beta testing mode, so it's not quite finished, but I'll take you through what we've So this is basically the dashboard that you start with, which gives you a look at all of the ferments currently active. You can filter these by different tank groups that you define, hide the empty ones, search by text for anything that you're particularly interested in, and then drill into those ferments specifically. So the way these are set up, we've got some basic info about the ferment at the top, your initial juice analysis, set up for the model parameters, and then a data table down here where you enter all of your Beaume and temperature measurements and any actions that you might do, so pump overs, DAP additions, overseeding, that kind of stuff. Over on the right, we've got the ferment graph, and you can modify this to hide or show any information that you're not actually interested in. And then we've got the what if and what now analysis. So these are basically create a temporary copy of the ferment that lets you mess around with any of the parameters to see how different changes would affect the model without actually changing the data that's saved in the database. So in this example that we've got a Riesling ferment that we have said we wanted to take 15 days, but we're currently at day 10 and it's still at 7.5 Beaume, and it's looking like it's probably not going to finish and get stuck. So we can come down to the data table and start looking at things that we could do to change this. So let's say, for example, we increase the temperature to 20 degrees and see if this is going to help it along. So rerun the simulation, which will take a few seconds, and we can now see the difference that this has made. So the light green line there is the original prediction that's kind of saved in the database, and the dark green is the effect of the change that we've just made. So this makes a big difference, but we're still probably not getting there quick enough. So let's see we can see what would happen if we also made a 100-part DAP addition. We get a little icon to say that we've made that addition. Rerun the simulation. And we're now finishing in kind of 23, 24 days, which may be enough, but you could try 22, see if that gets us there quicker. And we're now looking at kind of 20 days. So you could play with other things, maybe overseeding, see how that combines with a lower temperature, because maybe we don't actually want to run quite that hot for this ferment. And you can see how these different changes, how you can investigate these different changes before you actually go out to the tank and do anything. So the other mode that we've got is the what now analysis, which is basically a simplified version of the what if. So rather than having control over absolutely everything, you've just got quick control with these sliders of the main parameters that you might change within the model from the current time point only. So it's kind of a quick thing to just look at, what can I do today? So even if you're not terribly interested in the prediction side of the Ferment Simulator, it can still be quite a good tool just to have, a cloud-based ferment tracking tool. So there are a few different ways to enter data in for your different ferments. One, if we just come back to our example, one is to go through the data table for each ferment individually, but that can be a little bit cumbersome. So one feature which isn't quite implemented in this version but is being developed at the moment is we have a button here on the dashboard which will basically bring up a table of all your active ferments. There we go. All your active ferments that sort of kind of look similar to your Beaume sheet, and you'll just be able to put these in for the current time step in one go. So ferment profiles are another thing I just want to take you through quickly. These are a new feature that we've implemented in this version and basically allow you to define your standard practice for different types of ferments. So these give a bit of a guide for what the simulator should expect. You know, for example, if you let the ferment warm up a bit quicker, a bit higher towards the end of the ferment, or you're doing pump overs every day, or you know you do a standard DAP out at day 3, you can tell the simulator to expect these things so that it can give you a more accurate prediction. Without this, the simulator basically assumes that the current temperature is going to prevail through the duration of the ferment, which isn't always the case. So with this one, I've just designed a bit of a temperature path. So starting at 23, getting up to 26 by day 3 with a DAP addition, and then kind of cooling down for the remainder of the ferment with pump overs twice a day. So when I then go to set up a new ferment, you'd fill in all your information. When you come down to the ferment setup, you can select a profile that you've defined in the list, and it will then pre-fill your data table with basically your standard protocol for that type of ferment. And none of these things are fixed, so you can overwrite these temperatures as you go through and take your measurements from the tank. And it just gives the simulator a guide to give you a more accurate prediction. So we've created a number of different reports that you can generate for your ferments in a few different formats. So give you a quick demo of what they look like. We've got PDFs which basically give you all of the basic info about the ferment, the way you've set up the model, and the ferment graph for the current time point. Also get Excel reports which give you all of that information as well as the data table, and then JPEGs which basically just give you the ferment graph. So yeah, the Excel version gives you all your data as well for each ferment from the current time point. And then we've also got an archive or a history where you can download kind of an overview of all of the ferments that you've had either in the whole life of the winery, that you know, for the time that you've used the simulator or for the current vintage. And this can allow you to do some really interesting stats, you know, on average duration and average additions and all that kind of stuff. So being a cloud-based tool basically means that you've got access to your data wherever you are in the world from any kind of device. So it should display nicely on phones and tablets, though it is optimized on mobile devices more for viewing data than entering data, though you can still certainly enter data on those devices. You can also give access to whoever needs it in your business. So you can have your lab tech entering data on one machine, and then your winemaker log in from somewhere else and see how things are going. The data collected through this app will also contribute to the AWRI's research and extension work. So we won't use any individual data, it will all be used in aggregate anonymous forms. But the large amount of data generated will help us identify interesting trends and issues to focus our research, and it will also help the extension team to identify common issues through vintage and release targeted advice as early as possible. So the help desk won't get alerted or anything if you're having stuck ferments, and we won't contact you as a result of any of your data, but you can download your reports and send them to the help desk to give them a quick overview of what you're facing if you would like to contact them and get help. So all of this tool is kind of generating big data, and big data is a bit of a case of you don't really know what you can do with it until you've got it. One good example of this is probably in climate data. So, you know, we used to collect data manually and plot charts with pencil and paper, and then as weather stations started to improve and sensors were added, Networks were created to connect stations. We added satellites and started collecting ice cores and all these sorts of things. We're now predicting seasonal rainfall, El Nino and La Nina events, to things like global temperature rise to the year 2100. So climate data feeds all sorts of industries and businesses and is of huge national importance. And I doubt the guys who were, planning the first weather stations had any idea of what was really possible at the time. But now that we have the data, we find all sorts of applications for it. So I kind of envisage this being the case both at a business level with the stats that you can pull from your whole vintage data, and also at a system level for us in research and extension. So to the future, this is a tool that we intend to keep developing further, and one of the obvious next steps is for ferment sensors to be integrated into the simulator. There aren't too many wineries at the moment using ferment sensors, as it is quite a difficult environment for them to operate in, but there are a couple, and the AWRI trialled a few of these sensors a few years ago and found difficulties but also promise. So we had different issues with each sensor that we looked at, but these weren't things that couldn't be overcome with proper planning and engineering solutions. And we still see these as having a future in the wine industry. So being able to interface these directly would allow you to, you wouldn't have to do any data entry except for setting up the ferment initially, and you'd have access to live data from anywhere in the world, as well as predictions of how they're going to finish. So how do you get access? The Ferment Simulator will be part of the AWRI's Wine Cloud, and it will be available as a free module, unlike the other ones in there at the moment, which are subscription services. If you've already got an account, you'll just be granted access when the simulator launches. If not, you'll be able to sign up for a free account with Ferment Simulator only access, or you can, of course, sign up to the other modules while you're there. The app is scheduled for release in December, and we hope to have some of the last bugs ironed out in the next week or two. And if you'd be interested in helping with beta testing, feel free to drop me an email. I'll put my details up at the end. So as with all these kind of prediction type tools, I need to give a disclaimer. The tool is designed to help as an early warning tool, but it's not 100% accurate. It won't catch 100% of stuck ferments, and it doesn't replace good winemaking judgment. So if you'd like any more details on our general disclaimer, you can find that on our website. So thank you for listening. If you'd like more information about the simulator, or you'd like to sign up for alerts of when it will be released, you can do so at the webpage I've listed there, or you can just Google AWRI Ferment Simulator and you should get there. You can also contact me at either of those email addresses, and I'm happy to give you some more information. And I'll hand back to Michael.
Great, thanks very much for that, Tadro. We'll move straight from here into a Q&A, so if you've got any questions, Tadro's going to stick around for a little bit. Start sending them through now. I've just noticed we've got a couple come through already. For anyone that's not familiar, we need a reminder to send or to ask a question. Type it into the bottom part of your control panel and click to send. If you've got a microphone or you've dialed in on a phone and you want to chat directly with Tadro, please click the raise hand button. Okay, so I'm going to send you the first question now, Tadro.
Okay, so the first question is from Michael. Have you set anything up for bricks data instead of Beaumais? Yes. So, in the settings of the Ferment Simulator, you've got a lot of control over different units, so you can use the simulator in bricks or Beaumais. You can use temperature in Celsius or Fahrenheit. You can also set up the data tables for different frequencies of measurements. So if you're measuring your ferments once or twice a day, you can set up for that. So yeah, there's a lot of different settings, so you can customize how the simulator will work for your winery. So the next question is from Jonathan. How easy is it to change the fermenter names to actual tank numbers to make it meaningful, easier for wineries to manage on continuing basis, especially for high turnover tanks like red fermenters. Yep, so when you just get these out of the way of my screen. So you can set up the tank names however you like, and define different tank groups depending on how this works for your winery. Yeah, so you should be able to customize any of these names for how you need your winery to run. The simulator is kind of set up, I guess, with fermenters. So you would initially define all of the fermenters that you've got in your winery, and then go through, picking a fermenter when you want to set up a new ferment, if that makes sense. So the next question, can you do that in your Excel document as well as in the cloud? So I'm guessing you mean in the reports that you download, or the old Ferment Simulator Excel spreadsheet. Certainly in the reports that you download, so the Excel reports that you download, it'll use whatever tank names you've defined.
Thanks for your questions there, Michael and Jonathan. If you've got any follow-ups from Tadro's answer there, Jonathan, please send it through now. We'll stay on the line for another 30 seconds or so and see if any final questions come through, and if not, we'll wrap it up.
So just the last question from Jonathan about being able to change the fermenter names in the old Excel document. I don't think you can. I think the way the macros worked, it was actually using those fermenter numbers to know which ferment it was actually looking at. So yeah, we haven't done any updates to the old Ferment Simulator Excel sheet. Basically, this version is intended to supersede that.
Okay, looks like that's going to be it with regard to the Q&A. Thanks for following up there, Jonathan. Firstly, I just want to thank Tadro for presenting today. I'd also like to thank everyone who's logged in and attended and took part in today's session. For attendees, you'll receive a follow-up email with a link to the recording of this webinar. That email will also contain a link to a survey. The next AWRI webinar is on the 24th of November, where the CSIRO's Everard Edwards will present a webinar on targeted manipulation of vine balance. Now, if you'd like to register for this webinar and you haven't done so already, please visit the AWRI website. That's all we have for today. Thank you again for attending, and I look forward to seeing you at the next AWRI webinar.